architecture that are most relevant to people in the IETF, like with a definite bent toward the routing area, but sort of like general, useful for a general internet standards audience. After that, we're going to have like a super short panel discussion, which I just realized we don't have any chairs up here for, so maybe I'll organize that in the background while people are talking. Open questions. I will, seed the room with open questions if y'all aren't sufficiently awake to have any. So we have 75 minutes, so let's get started. I'd like to call up Charles Eckel to come give us an intro to 3GPP. Thank you very much.
We're not sure. If anybody's on Meet Echo, is video being shared yet? Somebody implied it wasn't. And
while we're checking on that, is the sound okay? Can you hear me? Great. I just want to second that. Thanks to people for coming in early. I thought we might be talking to an empty room and just relying on the recording, but yeah, I really appreciate you all being here. Are we good to go?
I'm not sure. We're double checking.
Don't have video.
Okay. Meet Echo is still working on the video, but I don't know if we should give them another 2 or 3 minutes, or if we should, because seeing as we're recording it, it's going to be on YouTube. Maybe it makes sense to.
They'll see the slides.
They'll see the slides.
Video. That's
perfectly
probably
fine.
more important. But so yeah, I'm Charles Eckel. Many of you know me from the hackathon. One of my more recent roles I've taken on is liaison manager to 3GPP. And then Peter, I saw you come in. Oh, here he is, Peter Schmidt. He's my counterpart on the 3GPP side. He's the liaison manager to IETF. So we work closely together on this topic. He's also the CT chair. And if you don't know what the CT chair is, hopefully you will by the end of this talk. We go to the next slide, please. So first of all, what is 3GPP? It stands for Third Generation Partnership Project. And you're probably familiar, it's basically the standards around these and how they communicate with the towers and how you're able to, communicate with each other across the cellular network. Much like IETF, a global organization, members spread across, the world. The project came together around the time frame when we were using 3G technology on the phones, and the name just stuck, even though now we do the more recent technologies there. One thing, though, that's quite different about the 3GPP is that, unlike IETF, where you participate as an individual, there you do really participate as your company, your organization. And in order for your organization to participate in 3GPP, it basically first joins one of these operational partners that you see on the right-hand side. And their kind of standards or industry groups across different parts of the world, and that's kind of one way in which 3GPP gets its global presence. If we go to the next slide.
You can also click if you'd like.
Oh, great. In addition to the operational partners, there's what we refer to as these market representation partners. And a lot of the more marketing-driven requirements come into 3GPP through those. I can see there's a number of those on the left-hand side. And then I mentioned that I'm the liaison manager to 3GPP, and similarly we have Peter here. There's a whole lot of organizations that to which 3GPP maintains an official liaison relationship. And you've probably seen liaisons come into IETF or maybe even sent them to various organizations, but that's a really big part of 3GPP meetings. They receive on order of like dozens of liaisons, exchange those back and forth with different groups, both internally within 3GPP, but a lot of external communication is done that way as well. So the liaison role is really used a lot within 3GPP. Whoops, okay, it's just a bit of a delay. Sorry about that, learning how the clicker works. So organizationally, there's these three what are referred to as technology specification groups, or TSGs. And I think of those as being kind of similar to areas in IETF. So you have your radio access network, you have your systems service and systems aspects, and then your core network and terminals. And that's where the CT group comes from. So Peter chairs that group. Now, within each of those groups, or as I think of them more like areas, you have multiple different kind of like working groups that you have in IETF, and you can see those listed there. Another thing that's kind of different here, though, is that the TSGs, they meet separately from the working groups, and they do so 4 times a year. And a lot of what gets done there is kind of more of the overall planning and coordination, both within and across the different TSGs. And then the working groups, they meet relatively independently as well. Oftentimes they do all come together. A large chunk of the working groups meet together, but they do sometimes meet in different locations on different schedules. So there's a bit more, I'd say, independence maybe there. And that's why they use the liaisons a lot to communicate with each other. And then finally, we have the PCG, the Project Coordination Group. And this is the one, kind of like the highest decision-making body. They're the ones I think help set up like the meeting schedule and where you're going to be and make sure that people are contributing to 3GPP. So maybe a little like our LLC that we have. Now, here's where they're very much, 3GPP is very much like IETF. Everything's contribution driven. And anyone who's a member of 3GPP can submit contributions to any 3GPP meeting. Then there's a lot of contributions that generally come in. They're formatted in a very specific way. And then they're used to build an agenda. And much like here, where getting consensus on things is super important, and that's the way things move forward. That's fortunately the way most things move forward in 3GPP as well. Generally, they try to reach consensus and get everyone to agree, and then those things move forward and can go into either a technical report or a technical specification. However, there are well-defined mechanisms in place in case those consensus mechanisms don't kind of break down or they're not able to reach an agreement on something. The other thing that's interesting is that in 3GPP, things are organized into releases. And so they really try to get a chunk of things that they're working on within a certain time frame and have that all come together as a release. And we'll talk a bit about that more in the next slides as well. So I mentioned technical reports and technical specifications. So the technical reports are more sort of informational. They're studies, and the output of those feeds into the technical specifications, which are more like our RFCs. Those are actually the normative work that 3GPP does. You can see here, this one that I'm showing, it's a TS, so it's a technical specification. Then there's a number there, 22, and that tells you which series it's a part of. And that makes it pretty easy to figure out like at least roughly what topic a 3GPP document is talking about. And then another important thing to notice, I mentioned releases, and you can see there's a release 19.0.0. Unlike RFCs where we have to do like say a biz version and you get a new number for the RFC, in 3GPP you have these long-lived specifications that are getting updated with every release and actually within the release. As often as every meeting, you can actually make changes, and you often do make changes to the technical specifications. So they're kind of incrementally evolving all the time. 3GPP uses what we refer to as a 3-stage delivery process. In stage 1, that's all about use cases and requirements. And in this example, and I'm talking more about the SA TSG that I mentioned earlier, because that's the one I'm most familiar with. SA1 is responsible for doing all that use cases and requirements. So while that's getting done, the other groups are actually working on other things. And then the outcome of SA1's work sort of feeds in and drives the work in all the other groups, as you can see here, both within TSG, and then there's some like impact they have on the other TSGs as well. And yeah, let me go on to the next one in the interest of time. So all that gets organized then in what we call a work plan. And so if you want to see what's going on in each of the different groups and the things they're working on and how it's all going to come together as a release, right now we're working primarily on release 19, but we're also working a bit on release 20. You can see that by looking at the work plan associated with each of these releases. And it does happen that multiple releases are maintained in parallel. Because of that sort of waterfall process that you saw, the stage 1, stage 2, stage 3, you can see an example here. Let's kind of just overlay this onto release 19 and release 20 that we're working on in 3GPP right now. The stage 1 work is all completed. The stage 2 and stage 3 work is actually happening on release 19. As soon as SA1 finished their stage 1 work for release 19, they moved on to release 20. So they're actively working on release 20 right now. So this is very common in 3GPP for multiple releases to be in process at the same time. And then, I also just wanted to mention the concept of releases we've talked about, but what about generation? So at the beginning, I mentioned 3GPP and 3G, and we have 4G, 5G. These are what we refer to as generations. And as you can see here, the generations span multiple releases. So right now, we're right at this point where I mentioned we're working on both release 19 and release 20. And release 20 is very interesting in that it's split across what we refer to as 5G advanced, so more advanced functionality for 5G, and actually the beginnings of some work for 6G. And all that work in 6G, none of it's actually going to be, I don't think the plan is for any of it to be normative. It's all working on those studies and long-lived studies that, that could span more. They really need more time than just one release. So the actual normative work will land more in release 21 for 6G. At least that's the kind of current plan. Then the last thing I want to mention is the coordination. I talked about this a little bit, how Peter and I work together, and at each IETF meeting, we actually have a coordination call where we talk about how things are going between IETF and 3GPP, go through the liaisons and dependencies. And that basically, I'll talk about those more in a minute too. But first, the liaisons. So I mentioned 3GPP contributions. The way liaisons come in, liaison statements into 3GPP are as meeting contributions. So when you want to send something to 3GPP, you actually need to format it specifically like 3GPP expects a contribution to be. It's very similar to how when you have an internet draft, it needs to be formatted a certain way and submitted. Liaison statements are sort of similar. So to do that, if you have your working group, you think you should send something to 3GPP, work with Peter and I, and we'll help you get like that formatting part of it correct. You can, of course, let us know what the content needs to be, but we'll make sure that we do the process correctly. And then dependencies. This is a big thing. Generally, it's 3GPP documents relying on IETF technology that we're all developing here. And fortunately, that happens quite a lot. In the best case, I guess, they're actually referring to RFCs that we've already published, but sometimes they do need to or want to refer to work that's in progress, either working group documents or even individual drafts. And in that case, when those references start to move from the studies into the technical specifications, the actual normative work, that's when we track it. Peter and I track it very closely because we want to make sure that that work in IETF that they're depending on, that 3GPP is depending on, that it actually makes it and lands as an RFC. And if there's any problems where we think that might not happen, we want to warn 3GPP so they can try to, perhaps move away from that dependency. And then just want to leave you with some links, links to 3GPP if you want to find out more information about a lot of the things I mentioned, and links within IETF in case you want to find out more about the coordination between 3GPP and IETF. And with that, I want to leave the bulk of the time for the real technical part, but I do want to acknowledge that these slides I actually got from a 3GPP newcomers quick start guide. I massaged them, repurposed them for this talk, but a lot of the material came from that, and that was something that Peter and others in 3GPP put together. So thanks to them for providing that material.
I was wondering if we have any questions. Will we flip over to the next one? I doubt it.
Yeah, we will have the moderated session at the end, but if you had anything before we move on this. Yeah.
Great.
Okay, thank you very much.
Thank you very much. There we go.
Good morning. My name is Jeffrey. I'm from Juniper Networks. I must say that I'm actually very new to the mobile wireless network technologies. I started getting involved a few years ago. I struggled a little at the beginning, so I thought that I would share my experience and my view of mobile wireless network as a routing or switching engineer. So I hope that may help some of us getting started there. So first, I'm going to talk about the 5G architecture, again, from a routing switching point of view. Talk about the GTPU tunneling and mobility and some use cases and services they have. The last topic, transport costs and slicing, I may not have time to get into that. That's fine. You can look at the slides and it should be easy to understand, and it's relatively on its own. So if you ask or search for a 5G architecture, very likely you will get this picture. It looks very daunting, so I'm not going into it now. We'll go back to our comfort zone. So in this picture, I have a data network in the middle. Could be internet or intranets. I have a router attached to that data network, and you may have a PC connected to it with an Ethernet cable. In this very simple case, the protocol stack is like this. On the PC side, you have the upper layer or application layers over IP and over Ethernet layers. And on the router side, the router has two stacks. One, well, no, I shouldn't say two stacks, but it has the IP over Ethernet on the left side towards the PC, and then on the right side, it has IP over lower layers, whatever layer it is, and then the router does the routing between the two sides. Now, in the Wi-Fi case, very similar. You have an AP in the middle. The PC2 connects to the wireless AP using a Wi-Fi area interface. Between the AP and the router 2 have Ethernet cable. And the protocol stack is very similar. On the PC side, it's upper layers over IP over Wi-Fi layers. And then on the AP, you have the AP is doing the relay between the Wi-Fi layers and Ethernet layers. And then it comes to the router R2, it's the same, no different from the first case. And then the third case is corporate VPN access. You have PC3 connected to, for example, IETF network, and you need to VPN back into your corporate network. And typically you have IP tunnel through that internet. And then basically you have R3 has the IP over that tunnel. And so that's how your PC3 is connected to the corporate network. So here, the protocol stacks involved are upper layers on the IP, and then over tunnel layers, and then on the router 3, you have the routing between the IP over tunnel layers and IP over the lower layers. And finally, let's come to 5G. Here, UE is user equipment. It's like our mobile phones or laptops. And in the middle, there is this Geno B. It's a device. You can sort of think it's like the wireless AP. Now, between the UE and Geno B, you have the area interface using the 3GPP protocols. And then between the Geno B and the UPF, the UPF is very much like a router when it comes to data forwarding. But now, between the Geno B and the UPF, you have the GTP tunnel that is through that IP underlay. And now the protocol stack is very much similar. On the UE, you have the application layer over PDU layer. The term PDU is used here. It's a 3GPP term. You can think of that as IP or Ethernet, and that's on top of the 5G RAN protocol layers. And then on the G-node B, again, you do the relay between the RAN protocol layers and then the GDP layer. Then comes to the UPF. You can think of it as a router doing routing and switching in terms of the data forwarding. And here you have the incoming traffic from the UE in the GPU tunnel. And then on top of the GPU, and then you have the either IP or Ethernet. And then on the right side, you just do the routing or switching into the data network. So commonalities between the two is all of IP over the lower layers. Or actually in the 5G case, you could also have Ethernet over lower layers. So whether the lower layer is Ethernet cable, Wi-Fi, tunnel, air interface, whether it's for Wi-Fi or mobile network, it's all very similar. The PC or the UE, the packet tool from those devices, they have the IP header, comes after lower layer header. And then they get their IP address typically from that router or from the UPF. And then the router or the UPF does the routing or switching to and from the data network. We talked about that wireless Wi-Fi AP, sort of like a G-node B there. Now, difference is that UEs can move around from one G-node B to another. So that involves mobility management. And in the Ethernet connection case, you probably don't need that access management, especially when you see in your own home. And in the case of Wi-Fi, you may have very simple password-based authorization. You know the password, you can get in. If you don't, you can't. But in the mobile wireless case, they have very sophisticated access management, authentication, authorization, things like that. Other functionalities is that UPF, beside the data forwarding, you have the billing and charging, other security slicing, all those other complicated or sophisticated functionalities. There is an important concept of COPS here, control plane and the user plane separation. We'll get into that later. So standardized management plan is part of the system. We'll not talk too much about that. So looking at this architecture picture again, so on the top part is basically their control or management plan. At the bottom is the data or user plane. And at least for me, I was really just focusing on the bottom part. For most of us, it's probably the case as well. You only need to focus on the bottom part. So we talked about access and mobility management earlier. So I highlighted those two boxes there. Those functions in the control plane handles that. And then data plane. So the SM function in the control plane and the UPF function in the data plane or user plane, that together, you can sort of think of it as our traditional router or broadband network gateway. And here, that's where the concept of COPS comes in, separation of the control plane and user plane. So you have, you probably will, well, you will hear this terms a lot, RAN and CN, radio access network and core network. As a network engineer, when you hear network, you sometimes very naturally the concept that the topology comes into your mind. But here, the radio access network or core network, they are more about functionalities than about the network or topology, things like that. It's not like that. You have access network and then you have a core network in terms of how the traffic are handled. But here it's really about the functionalities. So in the RAN case, you have GNOB for 5G and the eNoBs for 4G and so on and so forth. And in the core network case, basically you have all those functionalities that handles control plane and also the UPF. I think I'm going to skip to the next slide so that we can talk through this picture. So we talk about that the GNOB and UE. So traditionally the node Bs or eNoBs in the case of 3G and 4G, they are distributed and integrated. They are close to the towers. They handle all the functions together. But in 5G, the GNOBs are separated into, or it can be separated into distributed units, centralized units, and also radio units there. So they can be separate. And so when you have that separation, there is a need for the network to connect between those separate functions. So there you get into the terms of the front haul, mid haul, and back haul. Backhaul is the concept of backhaul is already there in 3G and 4G. It's really between the GNOB and the UPF, where that GGP tunnel are used. So there is a trend that with this GNOB disaggregation and the UPF distribution. So the CUs are moving away from the towers towards the center location, while the UPFs may be distributed closer to the edge for situations like mobile edge computing where the latency is important. So relationship between IETF and IEEE technology, I made a mistake. IETF and 3GPP technologies. Yeah, sorry. Yeah. So basically, mobile wireless networks provides basically IP Ethernet access services over a mobile infrastructure. That's basically the IP Ethernet PDU sessions. And they could even include the VPN services. In IETF or wireline sides, we are familiar with the concept of IP VPN or Ethernet VPN. 5G provides those services as well, the VPN services. The user plan, they are the interfaces, basically they are the GTP tunnels over IP. The GTP protocol is defined and maintained by 3GPP, but based on IETF technologies. So what a typical IETFer likely cares about is how we can provide IP transport securely and deterministically, and also the routing and switching functionality on the UPF. Charles already talked about this process model of 3GP a bit. So now I want just to do a very quick comparison between IETF and 3GPP. So in IETF, we have a very loose decoupled model. We specify individual protocols and features as building blocks. We have individual drafts adopt and then become a working group drafts and then become RFCs. They are feature by feature. The vendors implement those features based on their priority, most likely based on the requirements from the operators. And then the operators deploy those features a la carte. We don't mandate a management plan. And then in the 3GPP case, it's a strict software release-like model. Each individual features are proposed, discussed, and then admitted to a release. So if you go to a 3GPP meeting, it's like you're going into a code review session. Your proposals are discussed, denied, or accepted into a release So it's like very much like a code review. Managing plan is an integral part of each release. Then the vendors will implement releases, and operators will deploy the releases. So the interaction between the IETF and 3GPP, Charles already talked about the liaison process. And then some technologies are designed with close collaboration between the IETF and 3GPP. There are two examples here. A new RFC about the IETF slicing, have a close collaboration between the 3GPP and IETF, and a lot of liaison process was involved there. And ongoing work on the quick multipass, where the multipass can be either based on the 3GPP access or non-3GPP access. So GDP tunneling and mobility. So GDP stands for GPRS, tunneling protocol, and then GPRS means General Packet Radio Services. So it's basically IP UDP based communication protocol. It's a tunnel. A GDP tunnel has two kinds. One is a GDP-C and GDP-U. GDP-C was used for control plane, and GDP-U is used for user plane. Unless explicitly stated in this presentation, when I say GDP, I refer to GDP-U. So on the right side, you can see products, a packet with IP header, followed by UDP header, followed by the GDP header, and then followed by the payloads that is sent to or from the UE. So the GDP header, we don't need to go into the details, but I just want to call out those four bytes in the middle. It's called TEID. It's a very important concept. We'll talk about it more. So a GDP tunnel is basically identified by a pair, tunnel endpoint and tunnel endpoint ID. Here, I want to point out that tunnel endpoint ID or TEID does not identify a tunnel endpoint. It's assigned by a tunnel endpoint for a PDU session. So it identifies a PDU session, but it's called TEID. So it was a little bit confusing to me, but now I get it. It's so identify a session. It does not identify a tunnel endpoint. So here we have two data networks, the DN1 and DN2 connect to the same UPF. Then the UE1 connects to GNOB1, UE2 connect to GNOB2. Now let's say that the UE1 send traffic into DN1. So it send traffic to GNOB, and GNOB will put that into the GDP tunnel. So earlier we talked about the GDP tunnel packet includes IP header, UDP header, and then the payload. So in this case, the destination IP address is the UPF address, and that's the tunnel endpoint. And the TEID, which identifies that PDU session, it is learned from the AMF, the control part of that GNOB1. But that TEID is actually assigned by the UPF. So basically, the UPF assigns a TEID for a particular session, is sent to the AMF, and AMF sends it to the GNOB. So now the GNOB use that information to send traffic to the upstream towards the UPF, and the UPF removes that IP, UDP, and GDP header, and then it knows that from the TEID, it knows that which data network it belongs to. So in this case, the traffic is sent to DN1. Now, in the downlink case, DN2 sends traffic towards UE2. The UPF again put on a GDP header, which includes IPA header, UDP header, and a GDP header. So the destination address in that IP header is the GNOB's address, and the TEID in the GDP header is assigned by the GNOB, sent to the AMF, sent to SMF, and finally sent to UPF. So that's how the tunnel was set up and used. So some of us may be very familiar with the concept of IETF pseudowire. The pseudowire in IETF is actually very similar to the GTP tunnel. So in the GTP case, you have the IP or Ethernet payload for PDU session. That's the payload of the GTP, and it's identified by the tunnel endpoint and TEID. In the pseudowire case, you have a layer 2 payload between the two endpoints, and then the pseudowire is identified by a label that is used to reach the endpoint, and then the pseudowire label that identifies the pseudowire. So you can see that it's very similar, except the one uses label, the other one uses IP. Now, we talked about how the GDP tunnel is used in the earlier slides, so I'm not going to talk about that again in the GTP case. In the IETF pseudowire case, both ends of the pseudowire are provisioned with a pseudowire identifier, and then they send labels to each other, and that company established that pseudowire. We talked about COPS earlier. So again, the AMF and GNOB pair, and then SMF and UPF pair, you can sort of think that it's like the corresponds to the PEs in the pseudowire case. Mobility handling. So when the UE moves, it's attached it can move from one GNOB to another GNOB. So the old GNOB in 3GPP terms is source GNOB, and the new one is called a target GNOB. So when the UE moves, the GNOB may change, but the UPF does not change. So what happens is that the AMF will tell the new or target GNOB that the session ID of this moving PDU, it tells it the UPF address and the TEID assigned by the PDF by the UPF. So at this time, the target or the new GNOB can start sending the uplink traffic towards the UPF. It also asks the new or target GNOB for TEID, and that it tells that to the SMF. And at this time, we can ask the source or the old GNOB to release the tunnel resources for the session. And then the SMF will tell the UPF the new GNOB address and TEID. So at this time, the UPF can start sending the downlink traffic towards UE through the new GNOB. So there is a make before break mechanism used to ensure the session continuity. So there's no traffic loss and then provides the in-order delivery. So moving on to the third part of this talk, mobile edge computing and ultra reliable low delay. I forgot what C stands for. But anyway, so UPFs, traditionally they were centrally deployed. This is okay for the traffic to or from internet. You typically have very few UPFs and all the traffic goes through those UPFs. But there are scenarios where low latency is critical. And so application servers need to be deployed close to the UEs. in the edge computing data centers near GNOBs. That means that the UPFs also need to be deployed close to the GNOBs. So that's the distributed UPF case. So there are actually two ways to do this in 3GPP. I'm going to skip this ULCL UPF case and just talk about distributed UPFs. This again is a picture from IETF's point of view. So if you look at the picture on the left side, there are those UEs, mobile devices. They connected to access nodes here. Here, access node is a generic term. It could be a GNOB or some other non-3GPP nodes that provides the access, and then connect to UPFs. So here the UPFs are distributed closer to the GNOBs. And because of the UPFs are distributed here, so that also means that the data network they connect to are also distributed. And those distributed data network sites need to be connected together. And very typically, that connection is through the VPN, IP VPN or Ethernet VPN. So when you have the distributed UPFs, when the UE moves, most likely the IP address will change. Each UPF has its own block of IP addresses. It is possible to maintain IP address continuity when the UEs move around, attaching to a new UPF by basically advertising host routes. I don't think that's specified in 3GPP, but that is something that could be done if IP address continuity is a requirement. But at least if you're using Ethernet service, then because the MAC address does not change, so that is a requirement. And advertising those MAC address is very much like the IP host address if you are doing the IP instead of Ethernet. 5G LAN-type services. I mentioned earlier that 5G also provides VPN services, and this is my basic what they do. They call it LAN-type services. Typical consumer 5G services mainly involve traffic to or from internet, and the UE to UE traffic is rare. But in the LAN-type services that is used for business, the UE to UE traffic is normal. So in this case, you really want to distribute the UPF. And this is the same picture I had shared earlier in the earlier slide. So here, between the UE and UPF, it's either IP or Ethernet VPN services, and you can have different data networks for different customers. So that is very much like our VPN, but they have their own specification. But at service level, it's really the same as our VPN service. I will talk about this a little bit. So mobile wireless, they support roaming. You come to US, come from US to Europe, you're basically doing roaming. You are away from your home network. So if you look at the upper right picture, the bottom is the home network, for example, Verizon. And at the top is the visiting network, whatever operator here in Ireland. Your mobile device connect to the GNOB in the local visiting network. And eventually, you need to establish that PDU session between the visited GNOB and your home UPF. And that is through what they call intermediate UPF. If you look at the lower right picture, even you're in your same home network, there are maybe also situations where the operator specifically wants the GDP session between tunnel between the GNOB and UPF goes through some specific intermediate UPF for whatever purpose, for example, traffic steering. So there you have this IUPF concept in there. So for comparison, that IUPF is actually very much like the ASBR in the wireline networks, especially when you're doing the MPLS label swapping. For example, you have a VPN option B kind of services when the wireline network provides the VPN services across the AS boundaries. So how are we doing with time?
I think we probably want to go ahead to the panel discussion. We have like 15 minutes left. Can you do like a speed run of transport QoS and slicing in 90 seconds?
No, we don't need
okay.
to.
Okay.
That's fine. This on its own. I'm perfectly happy to stop here.
Oh, we have half an hour left.
Yep.
Oh, that's awesome. Keep going, please.
Okay. All right. So we talk about that between the GNOB and the UPF, we have this backhaul network, and we talk about the GDP tunnel is IP UDP. GDP tunnel is through an IP network, right? So that transport for the IP itself could be IP VPN over a converged infrastructure. For example, a provider could have converged infrastructure for both their wireline and wireless services, and then over that infrastructure, you could have IP VPN that is used to provide transport for the GDP tunneling. And so I have this picture here. You have the backhaul network. We have Ps, 4 Ps attached to that backhaul network. In the upper right corner of this picture, you have the AMF and SMF connected to the VRF1, where you have the N2 and N3 signaling running. By the way, the N2 signaling is between the AMF and GNOB. N3 is the user plane and interface between the SMF and the, I have that picture around here. Between the SMF and the VRF1, that should be N4 signaling. That is used to control the UPF. So if you look at the upper left part of this picture, you have the GNOB and UPF connect to the VRF1, and they are running the N2 signaling and N2 interface and N3 interface. So the N2 interface is used for control plane between the GNOB and AMF, and N4 signaling is used for the control plane between the UPF and SMF. And then the N3 is basically the GDP tunneling between the GNOB and UPF. So that's so that picture basically shows that how those control plane and user plane are transported over this IP VPN that is on top of that converged infrastructure. The interface between the UPF and data network is the N6 interface. Now, you can see that those 3 data network sites, 1, 2, 3, right now they are separated. So if you need to have the communication between the data network sites, they need to have some connections. So you can either have a separate connection network to connect those data network sites, or you can just do it through VPN again. So you have another VPN on top of the same transport infrastructure, and use a different VPN, a different VRF. And then now the 3 data network sites are connected over the same infrastructure. we talked about the X haul earlier, front haul, mid haul, and back haul. So QoS and slicing. On internet, QoS is coarse, is diff serve based. In the broadband access, the BNGs, they can provide the hierarchical per subscriber QoS on the access interface. And in case of 5G, you can have similar sophisticated QoS per UE, per subscriber. And here it's mainly for the radio interface for communication over the air. And then when the traffic goes through the GTP, and then the 5G's QoS is mapped to the QoS in the transport network. And QoS and slicing can be independent or can be intertwined. QoS can be provided with or without slicing, and different slices can have different QoS requirements or characteristics. I'll just talk about it at a very high level. So the general and 5G slicing. So basically, a network slice is a logical partition of a network for meeting a set of specific network performance objectives. So according to the 3GPP definition, a 5G network slice is a logical network that provides specific network capabilities and the network characteristics supporting various service properties for network slice customers. And in IETF draft, I forgot if that one has become RFC or not. Maybe it has. I think I updated one of the drafts into RFC in some of the slides, but I might have missed this one. But anyway, so on IETF, we have an interpretation of the 5G slicing is basically it has appropriate isolation resources, optimized topology. These resources are from the RAN, core network functions, and underlying infrastructure. So end-to-end 5G network slice can span across radio access network, core network, and they are transparently transported over a transport network. It shouldn't say transparent, it's really transported over transport network. We'll look at some pictures later. So then purely on the IETF side, we have the transport network slicing. It's basically a slice in the 5G transport network domain to isolate, guarantee, and prioritize transport network resources for slice services. And these resources could include buffers, link capacity, or even routing information base or forwarding information base. So there is this RFC 9543, talk about network slicing in the context of networks built from the IETF technologies. There is those terms and could be very tricky or subtle. It's best to read those drafts to get a better understanding. But here is a picture that is taken from this draft about using how to do the 5G network slicing through IETF network. You can see that at the top, there is a 5G end-to-end network slice orchestrator that talks to the RAN slice controller, IETF network slicing controller, and core network slicing controller. The two controllers on the side, they are on the 3GPP side, and then the central controller is on the IETF side. It's basically used to control the transport network. This is another picture. So at the top, you have the 5G slices end-to-end, identified by SNSSAI. I will not spell out what it means, but you can think of it as a slice identified by a number. And then you have the two slice and 5G end-to-end slices going through the same core network slice 1 and transported over IETF network slice number 6, and then come to the radio access network in the radio access network slice number 4, and so on and so forth. So again, quasi slicing, it's best to refer to those drafts to have RFCs to have a better understanding. It's just give a very, very high level overview here. So 5G architecture from a routing switching point of view, just think of it as IP or Ethernet over something, right? Over a mobile, in this case, is over a mobile wireless infrastructure. GTP tunneling is what makes it possible. And because of the mobility, your GTP tunnel endpoint could change on the GNOB side, but the UPF may not change, especially in the central UPF deployment case. But if you're using the distributed UPF, then when the UE moves, both GNOB and the UPF may change. 5G provides mobile edge computing, URLLC services, and LAN-type services. The LAN-type services is very similar to our IP Ethernet VPN. And then finally, the transport, quasi, and slicing. I really should refer to the RFCs and drafts for more accurate description or understanding. So, thank you.
Cool. Thank you very much. So we noticed two things while we were up here. One, there's no wireless networking. There is wireless networking on the stage. There are no wireless microphones on the stage. So my original idea of having everybody sit on chairs up on stage for the panel and pass a wireless mic around to them is not going to work because we have no wireless microphones or chairs. So if I could ask Peter and Charles to come up, I think we're going to try and get you some chairs at least, and then we're going to do a little bit of sort of a, yeah. Yeah. Can someone play like the Jeopardy theme music while we're...
Apologies to Meet Echo and the AV people if this makes you mad.
Cool. All right. You get to keep a chair. Yes. Yeah. No, you get a chair. Like,
I get a chair. Ooh. Wow.
So I just wanted to start with a quick, more of a remark than a question. As somebody who's sort of like basically seen what happens in 3GPP through the lens of like liaison statements sort of being yeeted over the fence, like just getting a very sort of like small slice, that wasn't a pun, of sort of how all of this stuff is supposed to work with respect to here's an architecture and here's some terminology I'm not used to. I hadn't really realized until this talk how much of this really is sort of very much all the same patterns with kind of different terminology, right? Like, so it's like it's set up to be super easy to understand if you just draw the boxes and lines and then don't label any of them. And as soon as you put the 3GPP labels on it, like my IETF brand is like, I don't understand any of this. So this was super useful. I don't know how it was for the rest of the audience. I mean, thank you all for sitting up here and watching me learn about 3GPP. This was great. So thanks a lot. I'm going to take the first question from the chat because I thought it was a really good one. If you're an IETF geek and you get your hands on like a 5G test lab, what should you play with to sort of like get understanding of what's going on? Oh, it's a really good question. I was like, Mike? Oh, right. I got to moderate. Sorry, it's early in the morning. There you go.
Well, I can give it a try. I actually have never got access to the mobile wireless network, except using my phone. So I would love to be able to log into it, connect to a UPF and check out all the status there and see how it is down there. Because to me, from data forwarding point of view, it's really a routing switching function. But I know that they are implemented differently. It's I think it's the open flow style instructions from the SMFs, and then for a routing engineer, it's kind of strange, but it is done that way. I would love to see it in action, but so far I have not been able to to do that.
All I can really think of is I would, pick what part you want to sort of work on. I mean, I think of it just very broadly in a few different steps, right? Basically your phone's talking to, a tower somewhere. So if you want to try to dig into that part, I've seen that sort of emulated where you can run some software on your laptop and actually have your phone connect to it. If that's, the part of the communication, the radio access network part you're interested in. But then I think for most of us, what probably hits closer to home and is more useful is, well, once you have this like tower, right, that's talked to your phone, and now it's actually on an IP network, and then the transmission across that. And then at the other end, you're often going to be going to maybe another endpoint, So I think I would just pick, one part and dig into that a little bit deeper, like with, and then see where, because there is an awful lot of IETF technology in there. So kind of starting from your own core strength and then build from there.
Maybe as an clarification, the point is, if you want to do something like this and go to a lab like this, the first thing you should have is a person who knows the equipment, that it can configure everything for you. Once it's configured, the protocols which are running there will look very familiar to an IETF guy. But until you haven't all these configurations, it might be very tricky. Because the real point here is, I'm not sure if that was really clear, when we are talking about these UPFs, what was mentioned here, it's a kind of gateway UPF. So it means operators do not allow that every UPF in his network is connected to his internet, only some of them. So if you set up a connection, then you have a G node B, you select the next UPF to it, and once this is done, and you want to have an internet, then you have from these UPF to the UPF which is allowed to go to the internet, you have a connection here. And this was in one figure, it was called the N9 interface. And this is then the point where we have then also these tunneling. And this also explains then, if you, for example, moving from one genome to another, the UPF which is connected to the internet is never changing. But all the other equipments are changing. And that's why we have this tunnel. And this tunnel is going with you when you're moving from one G node B to the next one. Maybe to make this clear, I'm not sure it was completely clear in the presentation. That's why I want to clarify this. And this configuration to make this clear that this happens, this is a tricky part where we need some experts for the mobile network. But for all these application layers, you will find the IETF protocols, you will recognize them a lot.
So summing up, it's hard, but it's easy, but it's hard, basically, right? Are there any questions from the floor? I think we want to do this sort of, we do have in queue. Greg.
Daniel.
Greg Shaw's ISC, but formerly 3 Mobile in the UK. So I understand a bit of the 3 and the 4G stuff. The 5G stuff is kind of interesting evolution. One of the things that from a traditional IP network kind of a person point of view is that we're all used to taking packet captures and looking at them in Wireshark. From a mobile network point of view, it seems a bit denser than that. It's just a whole load of boxes with weird labels on them. But is it, from the sort of kind of following on from the question, if we were to walk into a 5G lab and start playing with it, where would we start? is it possible to take packet captures? So at least you can understand the packet flow and the encapsulations going on at each stage, and start to put finger point and go, oh, so this bit means this here, and it goes over there and does this thing, and etc. Is that an easy thing to do in a mobile network? Okay.
If you have the trace capability installed as well, then you can easily follow this up. And you have all these traces which you can follow. And if, as I said, if you know the IETF protocols, then you can read this.
One other maybe interesting thing, I think the 3GPP networks, the security aspects of them are catching up, I'd say, to what you're probably more accustomed to in our in an internet environment. But a lot more things have traditionally been sent kind of in the clear, or, but now I think that's one of the areas, at least, where I see the most kind of involvement from IETF into 3GPP is, we've been working on various security protocols, even and much more of the 3GPP network is getting encrypted and getting safe. So sniffing things on the wire would be actually maybe a little bit easier than you might think in a 3GPP environment, but that is getting harder, I think, as security is being taken into account more and more. And that's an area where we're able to lend a lot of help from an IETF perspective.
Oh, thanks a lot. DKG.
Hi there, Daniel Kahn-Gilmore from the ACLU. So I'm actually curious about, you had mentioned that getting someone to configure the network first for you so that you can then play with it is the thing. I'm actually curious about those configuration choices, about what are the hard things to configure? What are how do, you mentioned some of the things are on the full internet and some of them are not. If there's a high level bit of, what would be the most interesting configuration choices do you have to deal with? And what are the most challenging things to configure, and how can the configurations go wrong? I would be interested in hearing about those. Just to, does that make sense as a question, or is it too broad?
It might be both. Okay, I'm going to put Charles on the spot.
Well, I mean, just to be honest, I haven't set up a 3GPP network, so it's
Point the mic at your mouth.
Oh, sorry. Yeah, I just don't have the experience at that level, actually configuring it and getting it to work. I've been working more on the protocols that it'd be using, but not not so much that end configuration. I would say, yeah, there is a lot of configuration involved. One of the, just a very simple example, one of the things I'm working on within 3GPP is the certificate management and how that happens. And I think traditionally in 3GPP, that's been much more of a manual process, or more of a proprietary, process. And so depending on how you do it, really depends a lot on the vendor you're working with. But that's an area where, in that case, the ACME standards that we have offer a way to sort of not only simplify it, but make it, one way of doing it that you can automate and actually write code to, as opposed to doing it, all that manually, setting up all your certificates and keeping them fresh and that type of thing.
So that's actually sort of where I'm going. I'm less interested in the particulars of configuration of a particular model. I'm interested in the questions that the configuration asks. So every protocol that we have, if you say, how do you connect to an IP network? Someone will tell you, well, you need an IP address and a net mask and a gateway at the very least, right? So my question is, what are those configuration choices? You mentioned certificates. You don't need a certificate to set up a standard IP network, but it sounds like you do. So who needs the certificates? Who consumes them? How do you make those decisions when you're setting up the network? Those are the kinds of questions that I'm interested in. Does sorry, I've already lost all the acronyms that you just shoved into my head. Does every I've lost the acronyms that you had on the slide.
So I mean,
but which pieces need certificates and which pieces consume them, for example?
So for example, in that case, all those different boxes in there, they're all part of what's referred to as the service-based architecture, and they all talk securely to each other. They're all using TLS. It's all HTTP, S, and so they all need certificates, and they need to be able to authenticate, to each other. And
okay.
Yeah.
Can I rephrase let me try to rephrase this question slightly in some terminology that I just learned 5 minutes ago. So like if we look at those boxes and lines, all of the lines also have labels on them, right? There's the in whatever, like the interfaces, instead of having like an X protocol, it's this interface. Are sort of the specifications of those protocols, would it be easy to sort of like extract what the configurable things are to the data models of those interfaces, or am I being naive about that? Because that I think what you're asking for is a book. And it's a book that I would like to read.
Not at the mic line. I don't want the book at the mic line, but I'm interested in sort of the high level pieces. Like, what are the most interesting parts that you'd want to?
And like what would we have to read and sort of like digest to get to that, I think is the question. You made a yeah. Sorry, you get the mic.
Yeah, the point is, for me, it's also a long time ago that I have configured something. At least, yeah, not sure. Maybe, Leonard, you have configured in the last couple of months something?
Maybe, Lionel Mon. The thing is that it's tricky because you have part of the information that you may find in the specifications, for instance, about all the parameters needed for the configuration of a specific traffic for a user and so on. But part of this, and most part of the configuration is out of the specification. It's under the mobile network operator control, saying that it will depend on your network and if you have legacy networks, not legacy networks, how you would like to set up. If you want to deploy only private network, for instance, your configuration will be totally different. So you will deploy VLAN, you will have this kind of stuff. So all this material is under the operator control, and it's not specified on purpose by the specification. So you have the main parameters that need to be supported over the interfaces. How it is implemented and how it is configured, it's up to the operator.
God,
So
okay,
it's
so
why
it's
it's tricky.
actually intentionally underspecified because it's part of the operations of the operator as opposed to.
Yeah.
Oh, okay. So you're asking for 2 books plus 1 for each network op. So sorry, we're running low on time. I do want to get to the rest of the Actually, DKG, I want to follow up with you in the hallway about this. This is a fascinating question. We have next Ayub. Yeah.
Hello, Ayub Missus, Huawei France, working on trust-related research. Thank you very much for this session. Obviously, a lot of people. My question, they were mentioned earlier in the second presentation about CUBs, control, user plane separation, which is basically clear separation. I wanted to refer to what are your thoughts about the separation between control and management planes?
Ooh, another good question.
What's the last part of your question?
Control and management plane separation. Because I think there's some sort of an overlapping. The separation is not clear. It's clear between user plane and control plane. What about management and control plane?
So maybe I wasn't using the term in a very strict manner, but when I say control plane, and I was more talking about how those boxes in the upper part communicate with the boxes on the bottom part. That's the control plane I was referring to. And the management plane, at least I interpret it as how all those boxes are managed, so that you can have all those functions come working together, sort of like how they are configured, provisioned. I think that's what I was trying to say. I don't know if that's the right words. I think Peter will have better. Yeah.
Yeah, these CUBs it's coming from the 4G area. In 4G, we had at the beginning we did not have a UPF, so the UPF was part of the signaling gateway, and then we identified that we have a lot of traffic ongoing, and that it's much cheaper to have this UPF, which is just a router, to have this separated and to have a multiple UPFs controlled by one controller. And now and that's the point between control plane and user plane. For the user plane, we just had the user data, and in the control plane, we had the signaling to set up the user plane. But your management part is then what I understood is how to configure the different nodes so that these control information on the control plane are working correctly. So these are completely different things. This management function is completely out of scope here.
So it's not something that we consider in 3GPP, I would say?
Let's say in this way, it's not standardized in this way, because this is how to configure everything. And this is based on each vendor how to do it. Because this is really hardware dependent. And in the moment we have a lot of different hardwares. So the management function on an overhead or from a top level point of view, it looks the same. But if you go to the deepest how to configure it, it's different for the different vendors.
And if we can add one grain of salt, which mentioning orchestration aspect. So how would you add orchestration into all of that mix? Because later on they will speak about orchestrations.
Yeah, I don't really have a question, but more Rusty, I posted some links in the chat, right? So because I think that I'm a practical guy, I want to play with stuff. So the problem is how do you can access some of these things and have people play with it, right? Because we were discussing traces, Wireshark, how does it work, right? So there is a project, which is Nephew, I'm involved in, it's open source. So you can actually spin up a free 5GC, which basically does a UPF, SMF, AMF, as well as an OAI project. So actually, and it does orchestration, right? So the purpose of that project is actually orchestration. But so I think it's a good way for people who want to play with stuff, and you can run it in the cloud or you can run it on your PC. So you just need a VM. And then you can actually look at all the protocols that are happening in between all these different things. And you can Wireshark. I think also this week, someone released a GTP Wireshark enhancement. So I think that will give you some practical guidance on how this thing works, and it allows people to play with it.
Thank you very much. So you just said that this week somebody added the ability to parse GTP to Wireshark.
Yes.
How long has GTP been deployed?
Very long.
Okay. That's it? Okay. Okay. Oh yeah. Okay. So it's interesting. It's interesting to see that we're catching up. So thank you very much. We're a little over, but Esko was in queue, so you have the last word.
Thank you. Yeah. So just to hook up to this same question and answer. So I'm actually a guy who started about 5 years ago from IETF, knowing nothing about 3GPP, and started working on that. So not anymore at the moment, but yeah, if you want to know more, you can talk to me. So I have just a few tips. So one is get a very good textbook, buy it.
Do you have tips for which textbook you should buy?
Yeah, I can maybe give.
Actually, can you if you put them quickly in the chat, then they'll yeah, that'd be great.
And there's also great online resources that I use. So I made one myself because I didn't think they were great. So there's one website, you type an acronym, you instantly get all the definitions and clickable links to the documents.
So I did have one question that I'll then ask you. Yeah. There is over in the left side of Jeffrey's diagram, there is the NNSSAAAC or something like that. How do you pronounce that? The really long one.
Yeah, to be
you pronounce it.
To be honest, there are like maybe 100,000 of acronyms and abbreviations. So you only work typically on the small part of those. But the tool is great, so you just type it if you're in a call or need to.
Cool. If you could put the links in the chat so that we have those for posterity, that'll go out into the proceedings of this. So thank you very much.
Yeah.
And I would like to thank our presenters, our panelists, all of you for waking up super early in the morning to come learn about 3GPP. As a reward for your enthusiasm, there will not be a quiz about the acronyms. So thanks a lot. Next up in here is Scone, also co-chaired by me. If you'd like to stick around for that, please stick around. If you would not like to stick around for that, what's wrong with you? But please do go ahead and head out so that we can get the room set up for the next session. Thank you very much. One goes down, one stays up. Jeffrey, I'll take that.
Thank you.
And then we should hold on. You got to do AV stuff.
Maybe as a hint, there is a TS which holds algorithms.
Okay.